Hi, I'm Bhavish, and in this video, we're going to look at a command called RGZPFM or Reorganize Physical File Member. So, this is a very important but often overlooked command and an operation which should regularly be performed on physical files which are usually modified when the records are inserted or deleted frequently. So, let's get into it and understand why it is required and why it is so important. So, let's begin. What is an RRN? So RRN stands for relative record number. As its name says, it is relative to the record. So when you have a physical file, let's say this is our source physical file for C++, where I have some random C++ code written. I have different columns and I have rows. So these are records and fields of a physical file or a source physical file. You will see that every record has a unique RRN number, which I have already selected by the RRN function. Now, if I am going to delete a record from this source physical file, the RRN number is going to disappear. What I mean by disappear is if I delete a record which is against RRN number 4, then it will delete the record, but it will never deallocate its space from the physical file. What I mean by that is the size of the physical file is not going to get reduced. The record will be gone. You'll not be able to extract it back apart from getting it back from a journal. But the RRN is going to be left unused. You will be having 1, 2, 3, then 5, 6, 7, 8, 9, 10. Let's just try that quickly. So let's just delete the record with RRN 4. So we'll select where RRN QCPPSRC equal to 4. So this is our record or the row in the physical file. We'll just delete it. Let's select it back again. You see, you don't get any record with RRN equal to 4. So let's remove it and see what all RRNs have left. Now we have 1, 2, 3 and 5, 6, 7, 8, 9, 10. 4, when we deleted, the RRN is never going to get reused again. If I insert a record in this source physical file, it will just add it at the end with the 11 RRN number. So now imagine if you have a very large source physical file or a very large physical file with a lot of accounting data, with a lot of transaction data, which gets deleted frequently. The new records are inserted in between frequently. So the unique record number. So RRN is a unique record number, which is assigned to each and every row of the physical file, and it never changes in the lifetime of the entire physical file unless you run the RGZPFM command. So those records which are deleted, those unique RRN numbers are never coming back. So those are lost numbers. Now you can have a very large physical file with the limitations of your system. I have asked ChatGPT. It says that you can have some 4.3 billion RRN numbers, and it refers to an IBM documentation. I'm not sure how much of that is true, but there is going to be some higher end top limit for the RRN for your system. When you have a really large physical file in terabytes and on a production system, then you cannot have wasted RRN records or wasted RRN numbers in the physical file. Also understand that you can run the reorganize source physical file only when none of your logic, none of your code actually utilizes the RRN number. Because if it does, and if the RRN numbers get reorganized and reallocated, then the code is not going to work properly, which is generally not the case. Usually, no logic will directly access a record by its RRN number. This remains hidden. This unique record number is usually hidden in the backend. You can look at it, you can play around with it, but it is not a good idea to write a logic to select a record based on its unique record number. And usually, software is not written like that. So, let's go back to our topic. What is RRN? So, we have understood an RRN is a unique record number. It's a relative record number, which is static for a record for its entirety of its lifetime. We have also seen what happens when a PF record is deleted. We deleted a record with RRN number 4 and the RRN number 4 got lost. It will never be allocated back to the physical file. What happens when a record is inserted into a physical file? So when a record is inserted, it will automatically assign the next available RRN number in it. So with this, your physical file will get RRN numbers which are not in a direct proper order. They will get fragmented. So these are some of the advantages, or why should reorganized physical file member be used. But before we go into this, let us try to execute RGZPFM ourselves. So as we see that the RRN number 4 is missing, when we run RGZPFM, what is going to happen is we will get the RRN numbering allocated back, starting from 1, 2, 3, 4, 5, 6, 7, 8, 9. So currently there are 9 records in total, but the 4th record is missing. That is why it shows till 10. But when we do RGZPFM, it will allocate the number 4 back to the number 5. 5 is going to get allocated to the next. So it is going to shift one record ahead, which is going to shift the numbering ahead. The actual source code should not change. So let's just do that. So RGZPFM, I've already done it in the past. I'll just re-execute. So RGZPFM, file name, and the member that you want to reorganize. So I've reorganized it. Let's look at the output now. You see now we have data from RRN number 1 to RRN number 9. 4 is now back. Also 10 is gone. So if you have a lot of such deletions, lot of insertions in your source physical file or in your physical file, they are going to get reorganized in the proper order as per the logical file. So you can also provide it a key by which you want to order it. So you can provide the logical file keys by which you want to reorganize the source physical file. So we are covering the basics of RRN, where we have seen that a deleted RRN is going to get rearranged. Moving back to our topic, why is RRN reorganization or reorganization of a physical file required? So the first advantage is reclaiming deleted record space. So now when you have a lot of deletions in a physical file over the years or over decades, when a file record is deleted, when a physical file record is deleted, it is not going to reduce the space. It is not going to reduce the size of the file on your disk. So it might very well appear to be deleted. The data might not even be accessible. In fact, the data will not be accessible, but the size of the file will not come down. So reorganizing a file will actually remove the RRN numberings from the physical file, and the file size will reduce drastically by the number of records you have deleted. It also improves the access performance. So since all the ordering is now proper in an ascending order, it is easy for the system to search or access a particular record in your physical file. So this is equivalent to defragmentation of a old hard drive on Windows. So when you have source physical file, there are members which are like source codes, different programs. So they have extents like the start and the end of the program. So it consolidates the members properly. That means the start of first member and the end of the first member is at a place, and then the second member start and the end comes after the first member start and end. So if you imagine you have a lot of source physical file members, so if you have 1000 programs and you keep on editing these programs one after the other, and if reorganization does not happen on its own, the start and the end is going to get messed up. Next is reclaiming disk space. So as we spoke about, even the original physical file size is going to reduce. Journaling and replicated environment size is also, the journal size and the replicated environment size is also going to get reduced. And we also spoke about the speed of access. So logical access paths are going to get rebuilt and access is going to be faster. An automatic reuse of RRN does not happen. So when we do RGZPFM, all the RRNs get reused. So there is no need to worry about the end of the last RRN possible or the end incoming of your very large physical file in a production system. So that was all for today. we've covered RGZPFM. If you do like these videos, do subscribe to the channel. Thank you for watching. Bye bye.